So I'm going to switch gears a little bit, talk about another structural feature of proteins and peptides in our drug discovery, and talk about disulfide bonds and analysis of those using mass spectrometry. So I'll talk just briefly about doing the disulfide bond mapping using mass spectrometry, and then I'll focus on something that we've been doing in the lab, generally what's called the triplet method, looking at the symmetric and asymmetric fragmentation of the disulfide bond using high energy CID. And I'll show you a little bit how to recognize the disulfide bonded peptides on the MALDI probe with the reduction on the probe, a very quick, and then recognizing the triplet in the fragmentation spectra of the disulfide bonded peptide. And I'll show you a number of examples with those triplets. I kind of put a lot of numbers there, so don't get scared. I made them so you can go back and recalculate if you want everything on your own in in your hotel room or back at work. So there's lots of numbers, but you can just do it yourself later on instead of just looking at them quickly here. So a general overview how we approach the disulfide bond mapping analysis. And in general, we use the enzymatic digestion of a native and reduced sample, and we just follow it by HPLC and compare those two profiles. Then we take the separated fractions and analyze, either using electrospray or MALDI, and sometimes 10 years ago, and I think even still now, some people use N-terminal sequencing for the analysis of identifying what came out from those specific fractions. You can also directly couple mass spectrometer to HPLC, use electrospray, and once again, they compare the native and the reduced digests of the potentially disulfide bonded peptide. The direct coupling has the potential of the peptide identification right away, and it's a quicker method than doing this offline, like in the first point. Then there's cyanylation of the partially reduced sample. It's a method that is really good for closely spaced cysteines, and so far I haven't seen anything else that will really work for the close and cysteine nodes. It's very time and labor consuming, but sometimes you just don't have any other choice. So you have to do modification of the reduced cysteine in a partially reduced sample that follows the chemical cleavage in a high pH, and fractionation of that sample, and then analyzing the fully reduced, each of the fractions that you obtain, and analysis by mass spectrometer. So as I said, sometimes you just cannot do this otherwise, but in many cases, what I will show, you can do the sequencing of the unseparated native digests, and if you can obtain your information of the disulfide bond network pretty quickly. So I generally look at the MALDI mass spectrum and apply the reduction on probe to very quickly scan the MS window to see what peptides are actually being reduced and what is missing after the reduction from the MALDI probe. So the reaction is set up really quickly, and if I go, this is the tryptic digest of HSA on the probe, and you will see the two spots that were not reduced on probe, and I specifically will show you this peak here, zoom on this area.